Let's practice solving some absolute value equations together that have some fractions inside the expressions. So for number one, let's take a look. We have the absolute value of this x over 3, or x divided by 3, is equal to 2. So in order for this to be true, one of two things could happen. Either this x over 3 would be equal to 2, or we could say that this x over 3 would have to be equal to negative 2. So if either of these things were true, then we would get solutions for this equation. So for the equation to the left, let's go ahead and get x alone and get a coefficient of 1. So we can do that by multiplying both sides by 3. So if we go ahead and do that, notice on the left side here, these 3's will cancel out to make 1. So we just have 1x, or just x. And on the right side, 2 times 3 is going to be 6. So that's going to be one of our solutions. I'm going to go ahead and move this over just a little bit. So for this equation here, same thing. Let's go ahead and multiply this by 3 over 1 on the left side and times 3 on the right side. Again, these 3 over 3 is just 1, so we have 1x, or just x. So we have x is equal to, and then negative 2 times 3 is negative 6. So for this first equation, x can be one of two things. First, it's going to be this negative 6, and then it could be this positive 6. Those are the two possible solutions. Let's check out another one. So for number 2, we have this absolute value of x over 5, or x divided by 5 is equal to 3. And we can make this true and find out what x is if we have this x divided by 5, if that's equal to positive 3. Or we can say if this x divided by 5 is equal to negative 3. All right. Now to solve each of these equations, each time we're going to try to get x alone. And so we're going to multiply both sides by 5, because that's going to get a coefficient of 1 in front of the x. So let's go ahead and do that to both sides of both equations. And if we take a look on the equation to the left, these 5's are going to cross cancel to make 1x. So we get x is equal to, and then 3 times 5 is 15. So there's one of our solutions. And looking at the other equation, these 5's are going to cross cancel again to make 1x, or just x. And then negative 3 times 5 is going to be negative 15. So we have two solutions here. X could be equal to negative 15, and x could be equal to positive 15. Those are our two solutions. For a third example, we have the absolute value of this x minus 3 over 4 is equal to 2. So let's go ahead and see. This could be true if we have x minus 3 over 4, if that's equal to positive 2. And then the other situation would be x minus 3 divided by 4 would be equal to negative 2. All right, so first things first, keep in mind that technically there are invisible parentheses here. The fraction bar implies that there is a grouping symbol for the numerator as well as the denominator. So first things first, let's go ahead and multiply both sides of the equation by 4. That way we can just have this x minus 3 alone, and both of these equations can go ahead and do that. So let's go ahead and multiply both of the equations by 4 on both sides. For the equation on the left, these 4's are going to cross cancel. We're just going to be left with this x minus 3, and that's going to be equal to, and then this 2 times 4 over here is going to be equal to 8. Looking at our other equation to the right, these 4's are going to cross cancel again, so we're just going to be left with this x minus 3. That's going to be equal to, and then this negative 2 times 4 is going to be negative 8. All right, so we have one-step equations here. Let's go ahead and use the addition property of equality and add 3 to both sides of both of these equations. If we go ahead and do that, then the equation on the left and the equation on the right, we're going to get on the left x is equal to a plus 3 is 11. And the equation on the left, we're going to get x is equal to negative 8 plus 3, which is equal to negative 5. So looks like we have two solutions here. X would be equal to negative 5 or positive 11. So those would be our two solutions. Here's a fourth example. Here we have this absolute value of x plus 7 divided by 3 is equal to 2. So let's see, we have this x plus 7 over 3, that could equal 2. And another scenario here we have, if we could make this x plus 7 over 3 equal to negative 2, then we could also find out what x would be to make this true. So let's go ahead and undo this dividing by 3. The inverse is going to be multiplying by 3. So let's do that on both sides of the equation. And let's do that for both of these equations as well. All right, so for the equation on the left, these 3's are going to cross cancel. So we're just going to be left with this x plus 7. And then this 2 times 3 on the right side is going to equal 6. For the equation to the right, these 3's are also going to cross cancel, so we're going to be left with this x plus 7 is equal to, and on the right side of the equation, negative 2 times 3 is going to be negative 6. Now to solve each of these one-step equations, we can subtract 7 from both sides using that subtraction property of equality. If we go ahead and do that For the equation on the left, we're going to get x is equal to -1. For the equation on the right, we're going to get x is equal to -13. So we do have two solutions here. X could be equal to -13, or it could be equal to -1. For number 5, we have the absolute value of this x minus 5 over 2 is equal to 6. So we can make this true if x minus 5 over 2. If we can find out when that's equal to 6, that would be one solution. And if we see when x minus 5 over 2 is equal to -6, that would be our other solution. So let's go ahead and take care of that divided by 2 by multiplying both sides by 2. Let's do that for both of these equations. So hopefully you're seeing that pattern get a little bit more clear each time. So for the equation to the left, these 2's are going to cross cancel. You're going to be left with this x minus 5 is equal to, and then this 6 times 2, that's going to be 12. For the equation on the right, these 2's, of course, are going to cross cancel. You're going to be left with this x minus 5 is equal to, and this -6 times 2 is going to be -12. To solve each of these one-step equations, the inverse of subtracting 5 is adding 5. So let's go ahead and add 5 to both sides of the equations. And if we go ahead and do that, we're going to get x is equal to 17, and we're going to get that x is equal to -7. So we do have two solutions. In one case, x would equal -7. In another case, x would equal +17. Here's number 6. In this case, we have this absolute value of x plus 9 over 6 is equal to 4. Let's go ahead and just take this expression inside the absolute value and set it equal to 4. And also we can say this x plus 9, if we divide that by 6, see if that's equal to -4. All right, so let's go ahead and do the inverse of dividing by 6. Let's go ahead and multiply both sides by 6. And we can do that for both of these equations. That way we don't have any fractions anymore. So for the equation on the left, these 6's will cross cancel. We're going to be left with this x plus 9 is equal to, and this 4 times 6 is going to be 24. And for the equation to the right, these 6's are going to cross cancel as well. We're going to get this x plus 9 is equal to, and this -4 times 6 is going to be -24. Solving these one-step equations, we can go ahead and take away 9 from both sides. Do that for both of them. And let's see what we're going to get. For the equation to the left, we're going to get x is equal to 24 minus 9 is 15. And for the equation to the right, -24 minus 9 is -33. So our two solutions here are going to be x would be equal to -33, or x is equal to 15. All right, here's a 7th example. Here we have the absolute value of x minus 2 over -4, or divided by -4, is equal to 5. In one scenario, x minus 2 divided by this -4 could equal this +5. In the other scenario, x minus 2 over this -4, we got to see when this is going to be equal to -5. All right, so first things first, let's go ahead and take care of that -4 that we're dividing by. Let's multiply the left side by -4. Let's multiply the right side by -4. Same thing for the equation to the right. Let's multiply both sides by -4. So -4 over -4 is just +1. So that works out nicely because we're just left with x minus 2 is equal to, and then 5 times -4 is going to be -20. For the equation to the right, these -4's are going to cross cancel again as well. And we have this x minus 2 is equal to, and then -5 times -4 is going to be +20. Now we have one-step equations, and we can go ahead and add 2 to both sides of these equations to solve for x. And getting x alone, we're going to see that on the equation to the left, we get x is equal to -18. And to the right here, we get x is equal to +22. So our two solutions here are going to be -18 and +22. In this next example, we have this absolute value of x plus 6 over -3 is equal to 4. And so we can say this x plus 6 divided by -3, if we can make that equal to +4, that'll be a solution if we solve for x. And for the other one, if we have this x plus 6 over -3, if that can be equal to -4, that will be our other solution. So what's the inverse of dividing by -3? Well, it's going to be multiplying by -3. So let's do that to both sides of both of these equations. So multiply both sides by -3. For the equation to the left, -3 over -3 is just 1. So we're just left with this x plus 6. Okay. And on the right side of this equation, 4 times -3 is -12. For our other equation, these -3's will cancel out again as well to make 1. So we have x plus 6 is equal to, And then this negative 4 times negative 3 is going to be a positive 12. To solve each of these equations, let's go ahead and just take away 6 from both sides. Go ahead and subtract, okay? And if we go ahead and do that, for the equation to the left, we're going to get x is equal to negative 18, and the equation to the right, we're going to get positive 6. So our two solutions here are x is going to equal negative 18 or positive 6. All right, for number 9, we have the absolute value of x minus 3 divided by negative 6 is equal to 2. So let's go ahead and set up our two scenarios. So let's go ahead and take that and divide it by 6. Let's see when that's equal to 2. And then we take this x minus 3 over negative 6, and let's see when that's equal to negative 2. So let's see, we're dividing by negative 6, so the inverse is going to be multiplying by negative 6. Let's go ahead and take care of that. And for our other equation, let's just do the same thing. So multiply both sides by negative 6. For the left equation, these negative 6's will cancel out to make 1, so we're just left with x minus 3 is equal to. And then on the right side, we have 2 times negative 6, which is negative 12. For the equation to the right, these two negative 6's will cross cancel again, and we're going to be left with x minus 3 is going to be equal to, and negative 2 times negative 6 is going to be positive 12. To solve each of these equations, we can use the addition property of equality and add 3 to both sides. If we go ahead and add 3 to both sides, that should isolate x nicely. So for the equation on the left, we get negative 3 plus 9, which is negative 9. And the equation to the right, 12 plus 3 is going to be 15. So our two solutions here are going to be x is equal to negative 9 and positive 15. Let's try another one together. For number 10, we have the absolute value of this 2x minus 5 over 3 is equal to 7. So notice how the coefficient for x is a different number, which is going to require just a little bit more work here, but not too much. So our first scenario is 2x minus 5 divided by 3. Let's see when that's going to be equal to 7. And our second scenario is going to be this 2x minus 5 over 3, and see when that's going to be equal to negative 7. All right, first things first, just like before, let's go ahead and do the inverse of dividing by 3, which is multiplying by 3. Let's do that to both of these equations. Multiply both sides by 3. If we do that, then these 3's will cross cancel for both equations, but for the equation on the left, we get this 2x minus 5 is equal to, and this 7 times 3 is going to be 21. For the equations on the right, again, these 3's are going to cross cancel. We'll get this 2x minus 5 is equal to, and then this negative 7 times 3, that's going to be negative 21. All right, so instead of one-step equations like we had before, we're having two-step equations. So let's go ahead and take care of these minus 5's and do the inverse, which is adding 5's. That'll go ahead and get us a nice 0. And so 2x would be equal to 26 in this case to the left, and then 2x would be equal to negative 16 for the case on the right. That leaves us with a coefficient of 2, but we really want a coefficient of 1, so we can go ahead and divide both sides by 2. If we do that, we're going to get 1x, or just x is equal to 13, and then 1x, or x is equal to negative 8. So our two solutions here we're going to see is going to be x is equal to negative 8, or it could be equal to 13. All right, for number 11, this one is actually pretty similar to number 10. It looks like we have another coefficient for x, so notice it should take another step as well. So let's say we have this 3x plus 6 over 2. Let's see when that's equal to 12. And we have this 3x plus 6 over 2. Let's see when that's equal to negative 12. All right, let's take care of this divided by 2 first by multiplying both sides by 2. And let's do that to both sides of both equations. First, these 2's are going to cross cancel nicely, just like we had planned. And so this 3x plus 6 is going to be equal to, and this 12 times 2 is going to be 24. For the equation to the right, these 2's are going to cross cancel. We're going to be left with this 3x plus 6, and that's going to be equal to, and this negative 12 times 2 is going to be negative 24. All right, so we have two-step equations here. Let's go ahead and do the inverse of adding 6, which is subtracting 6. Go ahead and do that to both sides of both equations. If we do that, we're going to be left with 3x is equal to 18, and 3x is equal to negative 30. To take care of these one-step equations, let's get the coefficient of x to be 1, and we can do that by dividing both sides of both equations by 3. 3x divided by 3 is just x, 18 divided by 3 is 6. 3x divided by 3 is 1x, which is x, and then negative 30 divided by 3 is negative 10. So our two solutions here are x could be equal to negative 10, or it could be equal to positive 6. Alright, here is one final example, number 12. In this case, it's very similar to the last few, we just have a negative coefficient though. So we have this negative 4x plus 12 divided by 2 has to be equal to 8, or has to be 8 away from 0. So let's go ahead and say, let's set this equal to 8, but also let's go ahead and set it equal to the opposite of 8 as well, because negative 8 is also 8 away from 0. Alright, so let's take care of this divided by 2 first by multiplying both sides by 2. So let's do that to both sides of both equations. And for the equation to the left, these 2's cross cancel. Lovely, then we're just left with this negative 4x plus 12 is equal to, and on the right side, 8 times 2 is going to be 16. For the equation to the right, these 2's will cross cancel. We're going to be left with this negative 4x plus 12 is equal to, and then this negative 8 times 2 is going to be negative 16. All right, let's take care of these two-step equations now. First, let's go ahead and take away 12 from both sides of both equations. If we go ahead and do that, let's see what's going to happen to each of these. For the equation to the left, we have negative 4x is equal to positive 4. And for the equation to the right, we have this negative 4x is equal to negative 28. Next, let's get the coefficient for x to be positive 1. So we can do that by dividing both sides by negative 4. So let's go ahead and do that to both equations here. So negative 4x divided by negative 4 is positive 1x, where just x equals. 4 divided by negative 4 is negative 1. For the equation to the right, negative 4x divided by negative 4 is going to be positive 1x, or just x equals, and negative 28 divided by negative 4 is going to be positive 7. So our two solutions for this equation are going to be x equals negative 1, but also x could be equal to positive 7. All right, so there you have 12 different examples of solving some absolute value equations where we had some fractions involved as well. So a little bit more work than maybe ones that don't have fraction bars, but just keep in mind that when you see a fraction bar, it groups the numerator and the denominator into two different groups. So just keep that in mind. Now keep in mind that all these practice problems in this video had two solutions, and it's because the absolute value expression was isolated on one side of the equation and there was a positive number on the other side of the equation, and that's not always going to be the case. If you want to look for some other resources where you have those different types of examples, take a look at some of the other worksheets or videos that I have on my channel. If you found the video helpful, please consider sharing it with a friend or classmate who might also find it helpful, and as always, keep with the great work that you're already doing.